The James Webb Space Telescope, JWST, a testament to human ingenuity and ambition, has embarked on a mission to unravel the enigmatic origins of the universe, challenging the foundations of our understanding of cosmic history as we know it. For decades, the Big Bang Theory, a narrative woven from the fabric of fire and chaos, has held sway, its echoes reverberating in every classroom, whispered in awe by cosmologists, and enshrined as the sacred origin story of science. However, the first images transmitted by the JWST have revealed a cosmos that deviates significantly from the predictions of the Big Bang Theory, leaving scientists grappling with implications that could potentially redefine our understanding of the universe's history. From the very outset, something was amiss. According to the Big Bang Theory, the universe should have been a chaotic, unfinished cosmos, still in the process of assembling. Instead, scientists found galaxies that were far too massive, too bright and too structured to exist so early in cosmic history. Some were fully formed just 300 million years after the supposed beginning of time, when the universe should have still been a quiet fog of hydrogen. These weren't cosmic toddlers, they were galactic adults, with organized rotations, dense star populations, and even signs of heavy metals, which should have taken generations of stars to create. One astrophysicist didn't mince words. These galaxies shouldn't exist, and yet they do. The JWST, designed to observe the birth of the universe, instead stumbled upon a cosmos that seems to have been born ready, not slowly evolving from chaos to order, but appearing in full costume as if the universe skipped rehearsal and went straight to the final performance. The Big Bang Theory isn't just about a single event, it's about a timeline, a sequence of cosmic steps from simplicity to complexity. Hydrogen gas forms first, then the first stars ignite, then galaxies assemble, then heavy elements emerge after several stellar life cycles. It's slow, it's messy, and it takes billions of years. But Webb saw something else. It saw galaxies with more mass than the Milky Way. Just 400 million years after the Big Bang, it saw stars embedded in those galaxies that already contained carbon, oxygen, even iron, metals that should have taken hundreds of millions of years to appear. And it saw a lot of these galaxies, not one, not two, dozens, maybe hundreds. Scientists tried to explain it away. Maybe the galaxies were misidentified. Maybe the redshift was off, but the spectroscopic data didn't lie. These galaxies were exactly as old and as developed as they appeared. This wasn't a statistical anomaly. It was a cosmic trend, and that trend pointed to one terrifying truth. Either time is lying to us, or the universe is. If galaxies are too evolved too soon, we must question the tools we use to measure their age, and that brings us to redshift, the sacred ruler of cosmic time. Redshift tells us how much the light from a distant object has stretched as the universe expands. The higher the redshift, the farther away and earlier in time that object is supposed to be. But what if that stretch isn't just expansion? What if something else is distorting that light? Photons losing energy not from distance but from interaction. This idea isn't new, it was called tired light, and for decades it sat in the trash bin of cosmology. But now, James Webb's data is pulling it back into the spotlight. Because if redshift doesn't mean what we think it means, then we may have misread the age of the universe itself. And that's just the beginning. Dark matter, the invisible glue that's supposed to shape and hold galaxies together, is also under siege. Webb is showing galaxies so organized, so tightly structured that they either formed inside dark matter halos that appeared too fast. Or maybe, just maybe, dark matter isn't doing what we thought at all. models that assumed slow, steady formation are falling apart, and new theories, plasma cosmology, cyclic universes, quantum bounces, are rising from the shadows. This is no longer about patching the cracks. It's about watching the entire cosmological framework begin to split at the seams. The Big Bang was never just a theory. It was a story of fire, birth, and evolution. But what if it was just a chapter? What if the universe didn't begin, but reset, or never had a beginning at all? That's the haunting possibility emerging from Webb's observations. As more galaxies appear that shouldn't be there, we may be forced to accept that the universe isn't telling us how it began. It's daring us to realize it never did. Among all the galaxies James Webb has revealed, one of the most unnerving discoveries isn't their structure. It's what's shining inside them, the stars. According to everything we know, the first stars, known as population 3 stars, were supposed to be massive, short-lived, and composed almost entirely of hydrogen and helium. No heavy elements, no complexity, just raw cosmic fire born from the simplest matter in existence. These would explode in enriched space with metals, allowing the next generations of stars to be more chemically complex. But Webb is seeing something that should be impossible. Stars that already show signs of metallicity. Stars that are rich in carbon, oxygen, even iron. And they're showing up just a few 100 million years after the supposed Big Bang. That's not enough time for multiple generations of stars to live, die, and recycle their matter into heavier elements. And it's not just one galaxy. It's a pattern across many of Webb's early observations. In fact, some of these stars are so large and luminous they push the theoretical limits of what's possible. They should collapse or never form. But there they are, defying every model we've clung to for a century. It's like finding skyscrapers in a village that was supposed to be just learning to stack bricks. Either the laws of stellar evolution were drastically different in the early universe, or our timeline is wrong, deeply wrong. And that changes everything from how we understand matter to how we understand time itself. Of all the galaxies James Webb has observed, a few are now becoming the stuff of legend. One of them is called CEERS 1749, and it shattered expectations the moment it appeared. Based on its redshift, this galaxy existed just 570 million years after the Big Bang. But here's the catch. It's not small, not dim, not struggling to take form. It's massive, luminous, and chemically evolved. It's rotating with the kind of stability that should require 1 billion years to develop. And at its center, evidence suggests the presence of a supermassive black hole, the kind that usually sits at the heart of well-aged galaxies, not infant ones. But CERS 1749 isn't alone. Webb has spotted others just like it. They appear too quickly, too organized, and too uniformly distributed across the sky to be flukes. If this were a rare event, we might chalk it up to a glitch in the data. But it's not. It's everywhere. It's the new norm. And it's whispering something unsettling. Maybe we weren't looking at the dawn of the universe. Maybe we were looking at a midday. A time not of emergence but of maturity. Which leads to a radical thought. What if the so-called cosmic dawn wasn't a beginning, but a continuation? Let's talk about chaos, or rather the disturbing lack of it. The early universe, according to the Big Bang model, should have been a turbulent mess. Quantum fluctuations stretched by inflation, uneven clumps of matter, a battleground of density where stars and galaxies had to fight their way into existence. But what Webb shows us is eerily smooth, too smooth. Galaxies aren't just forming, they're aligning. Their spins are ordered, their positions aren't scattered by random chance but follow strange, large-scale patterns. In some deep field views, galaxies appear like pearls on invisible strings, structured in filaments so vast they challenge the very idea of isotropy, the assumption that the universe looks the same in all directions. This too smooth problem is a dagger pointed at the heart of inflation theory, which was designed to introduce structure through slight imperfections. But what Webb is finding isn't slightly imperfect, it's unsettlingly perfect, like a system that didn't evolve from chaos, but was built with balance already baked in. If the universe was born in an explosion, why does it behave like a machine? As the data piles up and contradictions mount, cosmologists are quietly turning to ideas that were once considered fringe. Ideas like the steady state theory, which claimed the universe has no beginning or end, or the plasma cosmology model, where electromagnetic forces, not just gravity, sculpt the large-scale structure of the universe. Then there's the Big Bounce, a theory that replaces the Big Bang with a cycle, expansion, collapse, and rebirth over and over. And while none of these ideas are flawless, what's making them attractive again is simple. They offer more time to form stars, more time to grow galaxies, more time to develop structure, without rushing the entire cosmos into maturity within 300 million years. Webb has even sparked whispers about the tired light hypothesis, a rejected idea that says redshift doesn't come from expansion, but from photons losing energy over distance. Could we have misunderstood the very metric we use to map the age of the universe? These theories, long ignored or ridiculed, are now being dusted off and re-examined, because one thing is becoming increasingly clear. The Big Bang timeline no longer fits the observations, and when the evidence stops fitting the model, it's the model that must change. We built the James Webb Space Telescope to answer our most sacred question: how did everything begin? And for a moment we believed it would confirm our story, a fiery birth, a gradual unfolding, a majestic timeline from chaos to consciousness. But instead, Webb pointed its golden mirrors toward the deepest past, and the universe stared back with a secret we weren't ready to hear. It didn't whisper the story of a slow evolution. It didn't show us baby galaxies learning to walk. It showed us fully formed giants bursting with stars and heavy elements, moving with precision, glowing with maturity, at a time when nothing was supposed to exist at all. We thought we were looking at the first spark of a great cosmic fire. But maybe we were just seeing the embers of a flame that never went out. What if there was no beginning? What if the Big Bang wasn't the ignition of everything, but the echo of a cycle, the swing of a pendulum, the memory of a universe that had already lived and died before us? James Webb has not killed the Big Bang. It has done something more dangerous. It has unsettled it. It has raised the possibility that the timeline we trust, the rules we teach, the models we worship, may be incomplete or worse, fundamentally flawed. Maybe we were never meant to understand the origin. Maybe the truth was never hidden, just too complex for a single story to hold. So now we stand on the edge of a cosmological cliff, looking into a past that feels eerily like a future, with galaxies too big, too fast, too organized, too impossible to ignore. The models are cracking, the timelines are trembling, and the silence we once mistook for peace is beginning to sound like design. The question is no longer, where did we come from? It's what have we misunderstood all along? If this stunned you, if it shattered something you thought was unshakable, share this text, because the universe isn't just expanding, It's evolving, changing, and challenging us to keep up. And that's the most exciting part of all. The implications of these findings are far-reaching and profound. If the Big Bang Theory, the bedrock of modern cosmology, is found wanting, it could have ramifications for our understanding of the fundamental laws of physics, the nature of dark matter and dark energy, and even the very structure of space and time. Moreover, it could challenge our assumptions about the nature of existence itself, raising questions about the role of chance and determinism, the nature of complexity and simplicity, and the very meaning of life in a universe that may be more intricate and interconnected than we ever imagined. As we continue to sift through the data and refine our models, we must remain open to the possibility that the universe may hold secrets that we have yet to uncover. We must be willing to question our assumptions and challenge our dogmas, to push the boundaries of our understanding and seek out new ways of seeing and understanding the cosmos. It is a daunting task, but it is also an exhilarating one, for it is in the pursuit of knowledge that we find not only the key to our own past, but also the key to our own future. The universe may be more complex, more beautiful, more profound than we ever dared to imagine. It may be filled with wonders and mysteries that we have yet to fathom, secrets that are waiting to be discovered, and vistas that are waiting to be explored. It is a universe that has challenged and inspired us for millennia, and it continues to do so today. The James Webb Space Telescope has given us a glimpse into that universe, a glimpse that is both awe-inspiring and humbling, and it has reminded us that we are but a small part of something much larger and more mysterious than ourselves. And that is a truth that we would do well to remember as we continue our journey into the cosmic unknown. Cosmology is a field that is constantly evolving, and the discoveries made by the James Webb Space Telescope are just the latest in a long line of breakthroughs that have expanded our understanding of the universe. As we continue to explore the cosmos, we may find that our understanding of the Big Bang and the origins of the universe will continue to change, and that the story we tell about the beginning of everything may be just the first chapter in a much larger story. One of the most exciting aspects of the James Webb Space Telescope's discoveries is the potential for further research and exploration. With its unprecedented sensitivity and resolution, Webb is opening up new possibilities for studying the cosmos, from the first stars and galaxies to the formation of planets and the search for extraterrestrial life. It is a powerful tool that will undoubtedly lead to many more surprises and challenges to our understanding of the universe. As scientists continue to analyze the data collected by the James Webb Space Telescope, they are working to refine and test existing models of the universe and develop new theories to explain the observations. This process is ongoing and will likely continue for many years, as researchers sift through the vast amounts of data collected by the telescope and refine their understanding of the cosmos. One of the key challenges facing scientists is reconciling the observations made by the James Webb Space Telescope with the existing Big Bang theory. While the data collected by the telescope has challenged many aspects of the theory, it has also provided new insights into the early universe that could help to refine and strengthen the theory. For example, the discovery of so-called population 3 stars, which were thought to have formed very early in the universe, could provide valuable information about the conditions in the early universe and the processes that led to the formation of the first stars and galaxies. Another area of ongoing research is the study of dark matter and dark energy, two mysterious components of the universe that make up the majority of its mass and energy. The James Webb Space Telescope is well suited for studying these elusive entities, as it is able to observe the faint light emitted by distant galaxies and the cosmic microwave background radiation left over from the Big Bang. By studying these observations, scientists hope to gain a better understanding of the nature of dark matter and dark energy and their roles in the evolution of the universe. In addition to its contributions to our understanding of the Big Bang and the origins of the universe, the James Webb Space Telescope is also expected to play a key role in the search for extraterrestrial life. With its ability to observe the atmospheres of exoplanets, the telescope could provide valuable insights into the habitability of these distant worlds and the potential for life beyond Earth. The discoveries made by the James Webb Space Telescope are just the latest in a long line of breakthroughs that have expanded our understanding of the universe. As we continue to explore the cosmos, we may find that our understanding of the Big Bang and the origins of the universe will continue to change, and that the story we tell about the beginning of everything may be just the first chapter in a much larger story. The universe is a vast and fascinating place, and the James Webb Space Telescope has given us a glimpse into its many wonders and mysteries. As we continue to learn and explore, who knows what secrets it may yet reveal.